Welcome back. It's been a little while. This time I've got a really fun one for you, and we're going to try and get some physics working in SwiftUI. Let's get to it. So this time around we're going to try and create this little dangling rope thingy. Now there's going to be a little bit of math involved, but it shouldn't be too much. But the first thing we need to do is go through how we're actually going to build this. Now if you want to get straight to the code, you can skip this part or check out the GitHub link in the description. Otherwise, follow along and learn how to solve problems like a programmer. So this is what we'll be building. We've got a node at the top, a rope, another node, and we can have as many nodes as we like here. Now, I always find it easier to draw out these things first before I start programming. It gives me a better idea of what sort of classes and structs and stuff that I need to create. So just by looking at this, we can already tell that we need nodes, and we can see that we have these lines, these sticks. I'll call them lines. Okay, and there's something else about this which is interesting, is that we know that these ones move freely, and they're based on where they are and the gravity effect, and they also get pulled on by the other nodes around them. But this one up here is static, so that's a property that we'll need to put on our nodes. Let's say is locked, okay? Because one of them will have that property set to true. What else do we need? We need gravity. Properties on lines would be maybe length, and properties on our nodes would be their position. So we'll put coordinates. We might also need to know the angle of these lines, but I think this is enough for us to get started on. So I'm going to get started with some helper methods first, because that'll keep the rest of our code really clean, and all they're going to do is help us do some maths on CG points and such. Like it gets a bit messy if you're trying to like add and subtract X and Y values, and then your code lines get really long. But if we can just add and subtract CG points directly, that'll make things a lot more cleaner and easier to follow. Let's get over to the code. So to start with, we will create a new project, and I'm going with multi-platform app because in this project we're just using CG points, CG paths and things like that. We're not using UI Beziers or NS Beziers. So this is great. You'll be able to drop this code into any of your other projects that you like. I'm going to call this one dangle rope. Okay, so to start off we'll do our helper methods, and I'm just going to create a new file called helpers. So the first one I want to do is find the distance between 2 points. I think that will be important to get the length of the rope in between two nodes. So this will be called distance, and it will take in 2 CG points and return a CG float. So all we need to return here is the square root of x squared plus y squared. So that's simple enough. The next one I want to do is plus equals. So what we have here, you can see, is this in-out keyword. And this is quite useful because it will modify this CG point in place. So it doesn't return one in the function. Instead, it kind of returns it through the parameter. And I'll show you how that works a little bit later. You can see that these functions are quite simple. All I'm really doing here is trying to eliminate this kind of code and remove it from the other areas of our app. Make it as readable and easy to follow as possible. I'm going to add another one, which is minus. And this one here returns a CG point. Of course, we need a plus. And so the hope is with these helper methods, we'll be able to do something like 0.1 plus 0.2. Rather than rewriting all this out every single time we want to make modifications to our CG points. Okay, so I'm just going to copy and paste the rest of these. So we need some for divide and multiply. And in this case, I am doing it with a CG float against a CG point instead of CG point. And I'm also going to add this extension on CG point, which gives us a normalized point. I think also to clean this up even further, we can remove the names from the call site. Now, if we go back to our whiteboard, we can see that we need a node type and we need a line type. And we also need something that can put all of these together in some sort of structure. And I think I'm going to call that rope. And on the rope, we'll have an array of nodes, we'll have an array of lines, and then SwiftUI will use that information to draw. The other thing we need is a way to update the view many times a second so that you can get that animation and real-time feel to the simulation. So for starters, let's create a rope object. And I'm going to drag this into a model folder. Now we're going to import SwiftUI because I'm going to be using publishers on the variables in this class. And it is going to be a class because we're going to be updating it as it goes along rather than recreating it like you would with a struct. So like I said before, the first variable will be our nodes. Now we haven't got a node type yet, but I'm just going to put this in here as a placeholder. We will get an error, that's fine. And I'll call the lines sticks, I think. Now to silence these, let's create our node and stick classes. And these will need to be identifiable so that we can iterate over them in SwiftUI. And I'm just going to set the IDs to a UUID. Now remember that we need a coordinate for this, and I'm just going to call it position. And we'll also need to keep track of the previous position so that we can animate the change from one to another. And of course we have our locked property. And because it's a class, we'll need to create an initializer for it. We don't get them for free on classes like we do on structs. Better fix that. Okay, now let's create the stick class. This will be identifiable as well. The nodes and sticks are sort of similar in a way. Of course, we also need to add an ID for this. And each stick needs a reference to each node that it's connected to. So we'll call this node A, be a node. And we don't need to make these optional or anything like that because sticks can only exist in between nodes. You will never find one without a node at either end of it. Again, create an initializer. And here we get to use our first helper method. And that's it. How cool is that? So you can see here that I've also referencing self here. And the reason for that is because inside initializers, I like to reference self because it sort of gives you a way of differentiating between the input parameters and the actual properties on the object. Usually in other functions, I wouldn't do that. I wouldn't reference self. But that's just my code styling. So I'm going to move these out into their own files. Now we need a way to run this simulation. And that would involve updating the UI many times per second. And the way we can do that is to create a timer. If you've ever worked with creating computer games before, there is an update loop. And that's what we're essentially creating here. Now we need something that can call the update loop and set up the timer. So let's go toggle simulation, because I'd like to be able to stop and pause this as well from the UI. Now we need to keep track of whether the simulation is currently running, so let's create another variable for that. Now because we're using SwiftUI, the only way to really trigger the UI to be updating all the time is to change a value somehow. And so the way this is going to work is we'll just turn a boolean on and off many times a second, and that will force the UI to redraw itself. So when the simulation gets toggled, we check if the timer is running or is valid. And if it is, we will invalidate because this is the block where we want to turn it off. Otherwise, is running equals true. And we'll create a new timer. And I think I want to use the one with the block here, right? So we'll do it a fraction of a second. Yes, we want it to repeat. And inside the block, we will toggle the updater boolean and we will run update. And in here is where we will do the calculations for the stick rope thing. Before we do that, I also want to add a reset function so that we can wipe the board and start drawing nodes again. Obviously, if it's already running, you hit reset, you want it to stop, and we'll empty everything out. So let's go back to the update function, and we just need to loop over both of these nodes and sticks arrays. So for node in nodes, now we will calculate their new positions. Now, of course, the first node is locked, so we ignore that one and do not change its position. You grab their previous positions. So here we're going to set the previous position to its current position, and then we're going to update its current position. And this is where our other helper comes in handy. We do our plus equals, and we even got the minus here. It's at this point here where we now need to start thinking about gravity. I calculated mine at -9.8, and that's based on like actual gravity. But the thing is, I'm doing it multiple times per second. And this is why my simulation runs a little bit faster and looks a bit more wacky than what you would expect to see in the real world. And then we update the previous position. Now let's do the same for the sticks. We need to get the center of the stick. Actually, you know what'd be great here is if we go back over to stick and add this as a property. Looks pretty good to me. So if we go back here, we can just go for stick and sticks. Stick direction. I suppose we could do the same thing. If we head back, we can just go stick dot direction. Now down here we can go if node A is locked. It's also this calculation here that gives the rope its bouncy, stretchy effect. And this is why slight variances in these values is exaggerated the further you go down the rope. So the more nodes you have, the stretchier the rope is. And we're done. That's it. The model is finished. Alright, so now let's jump over to SwiftUI and start creating our node views and our stick views. I'm going to create a new group and call it views. And in here, I'm going to create a stick view and a node view. Import SwiftUI for both. And these are going to be quite simple. And we're going to use a path to draw these sticks. So pretty simple, we'll go path, move to node A, and we'll have it draw a line to node B. Now let's add a stroke. And I'm going to go with a line width of 4 around line cap. Delete these other ones. I'm going to add a dash. I like the idea of having a dashed line here. I think it looks pretty cool. Okay, so over to the node view. I think we'll go 15 by 15. You can make any of these adjustments you like. You can even set the color to whatever you want. I'm going to set mine based on whether the node is locked or not. And of course its position will be node.position. This is where the good stuff starts. I'm going to start out with the geometry reader. And the reason for this is because I'm going to be setting the screen size. So I'm going to start with the geometry reader so I can set the frame based on the size of the screen. If we don't do this, then SwiftUI is just going to shrink its window down to the size of its subviews. And if it does that, we won't have anywhere to add nodes. Now, of course, we need our rope, which will be a state object. Now here we've got our updater. And this is the value that's going to be toggled on and off, which is what's going to force the UI to reload. Now, the way this works is that I'll be duplicating code in both the if and else. So when this is set to true, it's going to update our nodes and sticks. And when it's set to false, it's going to update our nodes and sticks. A little weird, but there we go. Now let's just set up the rest of our view size real quick. I'm going to set the background to blue. Now we can use the for each loop here because our nodes conform to identifiable. And all we need to do is create the node view. Let's do one for the sticks. And we will just duplicate this code. You know what we could really do to make this a little bit cleaner is to create another view for these. So let's go rope view. We currently don't have a way of adding nodes to the screen. So we'll need to set up a gesture recognizer for that. And we are going to use a drag gesture. Why, you may ask? And why not use a tap gesture? Well, because for some reason, tap gestures do not give us the location that was tapped. So by setting the drag gesture's minimum distance to 0, it acts like a tap gesture on touch end. And when the drag has finished, we're going to create a new node. Position will be based on the drag end location. We'll set the lock to true if it's the first node in the array. So what we're doing here on the locked parameter is checking whether rope.nodes is empty. And if it's empty, it means this is the first one we're adding. And so that will be the one that's locked. And of course, we need to add a stick, and we can only do that if there is already a node present in the array. So we get the last one if it exists, and we add a stick. If it doesn't exist, we just add the node. Just going to build and run for a quick test to see if we can add nodes to the view. I'm running mine on the Mac. And look at that, we can add nodes and the sticks show up in between them. But we haven't got the simulation running yet, so what we need to do is add a toolbar with the start, stop, and reset buttons. So if it's running, we'll set the text to stop, and if it's not running, we'll set the text to start. The other button for reset. Thankfully, we've created that function earlier. Let's call it reset. We can adjust the window size, which is good. First node is red, it is locked. Add a few more. And I'll hit start simulation. And it doesn't work. Okay, so I made a mistake with the timer. So let's just jump back to this code real quick. And this is the reason why the sim wasn't working. If you have the same issue, hopefully you've watched the end of the video to check this out. So we need to change this to a scheduled timer. Okay, here we go. And there's our dangly rope. All done. Well, that's it for this video. I hope you learned something from it. I found it quite interesting that SwiftUI is capable of doing this kind of thing, and it's starting to make me think like maybe we can create games with it. I did write a book in 2018 called Simulations in Swift, and that uses Swift Playgrounds to run these kind of simulations with UIKit. But I'm thinking maybe I might do an update at some point which uses SwiftUI. I think that would be very interesting. Anyway, thanks for watching, and until next time.